Hello again, this is Borgdude on Clojure, and today I want to show you how you can build a GraalVM binary from a Clojure program. And to do that, we will go into a repository which has good documentation about how to do this, called CLJ Graal Docs. This is maintained by Lee Reed and myself, and the community, because everyone is welcome to contribute to this repository with scripts and tips to get Clojure latest working with GraalVM latest. So it has tips and tricks for issues that you can run into with GraalVM compilation. And but today we will just go through the hello world to make a very simple GraalVM binary, and just to see how you can do it. So nowadays I use pretty much tools depths for GraalVM compilation. So that is the first part of this hello world, but it also contains how to do it with Leiningen. And this approach I've also used a lot, but lately I'm migrating more towards the tools depths approach. So in this video I'll only be showing that. First you have to download GraalVM, so just follow this link, and then you end up here on the downloads page on GitHub, and you can download the latest version for your operating system. So I am on Mac OS here, so I would click this link, and then you will get a download. But I already did this, so my GraalVM installation, I always keep it in the downloads folder because I don't bother with keeping old versions around, and every quarter there is a new version, so I just keep it in the download and remove the old ones once I update. What I do after downloading this is set the GraalVM environment variable. So let's see, let me resize my screen a little bit for the video. Yeah, so you can see that I have set it to GraalVM home to downloads GraalVM 21. That is the latest. There is a slightly newer one which contains some fixes that are not relevant to me personally. So today I'll be using 21.0. So I will create a project like it is suggested here. So I will just go into my temp folder and then create a hello world folder. Yeah, okay, so hello world, source hello world. Okay, I will go into Emacs and go to the hello world, source hello world. I think I'll just call it the main namespace. Okay, so that would be hello world.main. I'm not sure what the tutorial calls it. Let's see, maybe it calls it core. I usually call the namespace where the main function will live, but that will be invoked from the command line. I usually call that main now, because core pretty much means the core API in Clojure, but that's just a minor nitpick. So let's go to depths Eden. So now we have Clojure 110.2. That's already old because there is 3 now, but shouldn't really matter much for GraalVM compilation. So now we put the namespace, the hello world namespace here. I call it main, so we'll change this. So you can run this using normal Clojure. So we do Clojure -m and then m hello world main. So if it works correctly, we will see hello world. Yeah, okay, once again, hello world. So this is just using the JVM, and this is not a binary yet. But now we can compile these. We can compile this Clojure code to bytecode. That is done using the Clojure compiler. So for this, we make a directory called classes, where the classes end up. This is the default path where Clojure emits classes. Now we can compile our main namespace. So if we look in the classes directory, we see Clojure and hello world. Classes hello world main. So this is, so we see the main class is compiled here. Okay. So we can invoke the compiled program using Java without Clojure compilation anymore. So we put the classes directory on the class path, and then we invoke hello world main. That works. So this is just a step to verify if things work correctly. So now we will make a compile script to compile this Java program to a standalone binary. So we copy this script. My convention is to have a script directory in the root of the project, and then I call it compile. So yes, create it. Okay, and now I will change the permission for this compile script, and now shell mode, I think, or no, what is it called? Shell? No. No, this is not right. So I will reopen the script. I never know how to trigger the bash syntax highlighting, but it just reopen it. So there are a couple of issues with this script, because I have a linter also for bash, and so yeah, but this is actually correct. So the linter here is nagging about something which it shouldn't do, because I just fix it. So, and we have to escape this. So this script assumes that you, so I fixed all the linter warnings. So this script assumes that you will set the native image environment variable. I don't personally like this, because GraalVM comes with more binaries than native image, so I prefer to set the GraalVM home variable, which I find more flexible to use. So we will change the script, and I think this is also advocated by the GraalVM developers. I see this pattern in their scripts as well. So once you set the GraalVM home variable, you can then say bin and then native image. But first, so native image, it comes with GraalVM, but you have to install it first. So I usually also put this in my script. This is an installer program, GU. I'm not sure what it stands for, but you can say install and then native image. So let's test it actually from the command line. Yeah, so it is already installed, so it doesn't matter. The return code is 0, so you can invoke this as many times as you want. It will just ensure that the native image command line tool is available. So now we will compile the native image, the program with native image. So we set the class path once again, and then the name of our program will be hello world. Now we this is some better error reporting. So for Clojure, you usually need initialize at build time, because else you will get strange errors. And so it's better to initialize everything at build time, except for some classes, for specific libraries that need initialize at runtime. So you can override this for specific classes. I need this for a Postgres driver, I think, and some, well, for some libraries, but you don't need this. You don't need to override this with many libraries. So verbose will just output more information. This flag is very important, because if the native compilation fails, then native image will basically create a fallback image, which is a full JVM, which will just run your program on the JVM. But this is almost never what you want with native image. So I recommend always use this flag, and also no server, because if you don't provide this flag, then GraalVM will start a server on the background, which will be reused for the next time. But I find that unnecessary crap on my system. So I just turn that off as well. And here you can provide extra JVM flags. So this flag will only use, just a moment, the phone is ringing. I will pause the recording. Yeah, I'm back now. So you can provide extra JVM flags with -j, and then we provide XMX 3 GB here. So GraalVM will just take 3 GB for compilation. You can increase this, and then the compilation will become usually faster. But on CI, if you are compiling on Circle CI, for example, you will only get 4 GB by default. So you don't want to push this too high, because else your compilation will fail with I think a 127 or 137 exit code, which means out of memory. And now the final argument is hello world dot, well, we call it main. So this is the main class that will be invoked for, which will be the main entry also for our program. So I think we've all set everything up now to be able to compile. So let's see, script compile. So now we've already compiled. So I usually also include the Clojure. So we'll just keep this running. So this is GraalVM. Oh, it's pretty fast actually. So just let's wait for it. So this is just the simplest possible program that you can have. What did it say? Line 20 and command not found. 20. Not sure. But let's see if our Hello World program is available. Yeah, it's available, and it's only 8.8 gigabytes. So let's, can you see this? Oh. Yeah, so I'll just invoke it, and you see that it works. So time, it's very fast. It's only 13 milliseconds. Excellent. So let's see, what was the script? What was it complaining about? I don't know, maybe because I was editing it. I usually also include the compilation step in my compile script. So when I change my program, everything just works. So let's hello world, and then maybe what should we print? Well, maybe also the time it took to execute this. So let's test it from Clojure. Hello world, elapsed time 22 milliseconds, dot 22. So let's try our compile script again. So Clojure will compile, that's over here. Hello world main, and now GraalVM will compile our program with the changes. And so when developing GraalVM binaries on the with Clojure programs, it's usually better to just test them on the JVM and only in the final stage compile them, because compiling does take a while, especially if your program is larger. So now we did hello world, and you also see the time printed. And this is pretty cool because it's pretty small, and if we copy this, copy hello world to temp, and I'm oh cannot over, of course, yeah, I've already, so let's copy the hello world binary to temp hello. So if I'm in a different terminal now and I go to temp, so I'm outside my project, it still works hello, right? So it's pretty standalone, but this binary is dynamically compiled, which means that it still will need some pre-installed libraries on your system. So you can view on macOS, you can view this with O-tool, the -L, and then hello. So here it shows which libraries from your system it uses. So it uses userlib, libsystem, dilib. So this is pretty standard on every macOS installation. These libraries are available. So it means that this binary uses these libraries in the background. And this is usually not a problem. And it's even better than if you statically link everything, because these libraries are more up to date on your system than if you compile it against some older versions. So dynamic linking is preferred, I think, in most situations, except when you compile for a Docker image, which should be very small. And in that case, if you compile for Alpine, for example, in that case you should also use the static flag. So that is like this. But this static flag, so it will produce a standalone binary which does not depend anymore on any library on your system. But this is only supported for Linux. And the intention is that it's used in Alpine Docker images, for example. So Babashka, for example, is compiled using GraalVM native image, and it has dynamically linked executables, but also a static one. So if you go to Babashka and then releases, yeah, then you can see here we have Linux, but also Linux static. So if you are running Babashka in a Alpine Docker image, you will need this one. So there are some limitations to what you can do with GraalVM, because you cannot compile new bytecode in a native image. So it's a closed world where all the compilation already happened. So I will show what goes wrong if we try to evaluate something. Eval, let's see, we will just the arguments. So the first, we will parse the argument as Eden, for example. Require Clojure.Eden as Eden. Yeah, that looks right. So now we do a Eden read string first args. And now we will evaluate something at runtime. And now we will print the result. So let's try it with Clojure first. cd hello world minus m. So we do plus 1 2 3. That should work. And I'm not sure if this needs bytecode compilation. I think it does, but surely if we create a function that returns foo and we call it, this surely requires compilation. So this works with normal Clojure, but if we compile this, let's try it with GraalVM, this will fail because you cannot do compilation of bytecode in a native image and then run it. In the future it might be possible because there are some new developments. So there is now a Java version that runs in GraalVM, but that's quite experimental, so that's not there yet. So you will see now if you try to do this, you see the class loader is reachable. So and this is something that is a limitation of GraalVM. So you can, if you hit this error, you can work around this by saying report unsupported elements at runtime. So let's include that in our script. But then you will see the error at runtime and not at compile time. But in some cases this might be okay because the eval case might never be hit in your for your use case. So then it's fine to just work around this using this flag. But if you really need the eval at runtime, then you will see the error at runtime with this flag. So that is what this flag is for. So let's see what happens if we execute hello world with some function that we define at runtime. So wait for the compilation to finish. Okay, there it goes. Hello world with a function. Okay, clear. So let's try this. And now it says, this is weird, right? So it has some spec error, which is a little bit weird. But we can turn spec checking. I don't know. Ensure macro spec. Could not locate Clojure spec alpha. I'm not sure. It might, but we can turn the macro checks. We can turn those off as well using JVM flags. So I think I have this in Babashka script compile. Let's see, and that is this one. But maybe you even, yeah, okay, let's put those flags in as well. Okay. So direct linking is not relevant to what we're doing here, but that's another optimization you can do. Skip macros, skip macro checking. Okay, let's try compile again. Let's see. But this is surely, this is a limitation of GraalVM. You cannot do this, and this is the reason why I developed Psi. And Psi is a Clojure interpreter that is compatible with GraalVM, and you can evaluate strings using it, and that will work in your GraalVM binary. So if you run into this limitation with eval in Clojure and you want to make some kind of scripting tool, then take a look at Psi. I will do probably another video about this at some point to demonstrate how you can use Psi to make a little scripting, Clojure scripting tool like Babashka. So yeah, it's done now. So let's see. Hello world. Okay. So now we hit the real issue. Unsupported method Java long class loader define class is reachable. So that's just not possible. You cannot do eval. So maybe simple things do work. So if something like this, no, not even that works. So it's a number. Yeah, a number works. Just a simple number. And this one already doesn't work. It already needs the compiler. So for very simple stuff, no, you already need the compiler to do this. And here, this is another issue. So here we try to add some numbers, but now it says, well, I could not find this class. And the reason is GraalVM does static analysis of your code, but in our code we never used the plus anywhere. So it did not know it needed the class Clojure lang numbers at runtime. And so you can solve this by making the numbers class available at runtime by adding it to a reflection configuration. So let's do that, reflection.json I usually call it. And then you can put a list of classes here. So name, so this is the name as a string. And I usually forget which. Yep. That was my wife asking a question. I will wrap this video up soon after the reflection configuration. So let's see. In Babashka, I also use this extensively. So this is the reflection configuration for Babashka, and this is the settings I was searching. So I will just put I will save all public methods, fields, and constructors for the class Clojure lang numbers. So this will be available at runtime. And now let's see, in the compile script of Babashka. So you can say reflection configuration files is reflection.json. It does have some defaults. So if you put this in the meta inf folder in some specific location, it will automatically recognize the reflection config. But for now, I just set it manually. So I think we can solve this problem by setting the reflection JSON. Let's try it one last time. Compile. One last time. This is, I didn't rehearse this. This is all improvised. Okay, let's wait. Okay, there it goes. One last time. And if everything works okay, you won't see that it cannot resolve the class numbers anymore, because that is available at runtime in any case, because we put that in our reflection configuration. Okay, let's clear. Let's try it one more time. So now, yeah, now it has the issue again that you cannot define a new class. So but we don't see the issue about the numbers class anymore. But so this is the limitation of native image. But for other cases, so if you don't need eval, and most programs in Clojure actually do not need eval after compilation. So there is a wide range of libraries that you can use with GraalVM that just work without any special tricks, like this Hello World program. And there is a so I just walked you through this Hello World, but if you need a list of libraries that are supported, you can go to external resources, and here we see a couple of projects that use GraalVM. This hasn't been updated for a while. I think there are lots and lots of more. And these are some libraries that are compatible with GraalVM. But there is another repository, GraalVM Clojure, which lists many more of them. So you're free to add to these documentation libraries if you have discovered that something works or doesn't work with GraalVM. So this is it. This is how you can make a small Hello World command line application with GraalVM. I hope you liked it. If you liked it, give this video a thumbs up or subscribe, and you can sponsor me on GitHub for my work on Babashka and Clojure and Sai, Babashka, Sealjekondo and Sai. Just go to my profile, WorkDude, and you will see here the sponsor button. Sponsor, I think if you view this in the incognito window, you will see it. Yeah, you can hit this button and then you will see some options. So thank you very much for watching. Please leave any questions for maybe next topics for videos, or hit me up on Twitter or Slack, Clojurian Slack. See you next time.